Hello guys, welcome to EmbVerse. Today we are discussing this automotive project called Body Control Unit. Here we are controlling 3 lights using 4 switches. Let us see how. So for this we will be simulating it on TinkerCAD. So let's first log into our account, press sign in. I have an email account, so I have already signed up on this through an email account. I just enter the email ID and the password and then sign in. Once you sign in, you arrive at the dashboard, and here you can see various options like 3D designs, circuits, code blocks, lessons. We are interested in circuits. I already have a couple of projects, but let us create a new one. So click create new circuit. And this is the canvas that we have. Okay, so you can, here is the project name. They give random names. You can always change it if you want to. So I will change it to project 1, and you click somewhere and name is changed. So how do you start off? You can drag and drop whichever components you would like to have in your circuit. Okay, say the resistor, LED button, push button, sorry, or if you cannot find any of them here, you can always type it and search for it. So I'm going to search for an Arduino. Here it is. Drag it out like this and place it. So that's how you bring out components from the library to your workbench, if you would call that. And here you can see, wait, I'm doing this on a laptop, so yeah. So we have a resistor. If I click it, you can change the resistance value here. You can see these color bands also changing. You can change it from kilo ohm to ohm as you like it, and the LED, you can change the color like that. You can always fiddle around here, and yeah, this is how you make connections, right? And you can change the wire colors also if you wish, and yeah, you can add labels too, like so. What do you say? Analog pin, enter. Hey, it's analog. Wait, okay, I'll let that be. So suppose you don't want to see that now, hide it pressing this button. So that's a very quick startup guide. Now we will go to the main project that we are supposed to discuss today. It's the body control unit project. So I've already got the circuit set up here. So like you can see here, there is a benchtop power supply, there are 3 relays, there are 3 lamps, 1 LED, an Arduino, and here we have some resistors and 4 switches. Okay, so there is a parking light. I'll show you the labels. Oh wait a minute, no, not this. Okay, yeah, so I'll show you the labels. You can't see anything. Okay, now you can see. Yeah, so here's the parking light, fog light, headlight, and the auto mode LED. Okay, parking light, fog light, headlight, and the auto mode LED, and this is the benchtop power supply. And then correspondingly we have arranged the switches. Okay, first is the parking light switch, second is the fog light switch, third is the headlight switch, and fourth is the auto mode switch. And you can see the corresponding inputs, so it's actually inverted here. This is the parking light. It is connected to pin 2. Okay, 2 for parking light, 3 for fog light, 4 for headlight, and 5 for auto mode LED. Okay, so I'll just show you, and here we have the ambient light sensor. Okay, this will be used during the auto mode. Now let's see a quick simulation. Okay, if you've already put in the code, okay, without the code you cannot simulate, remember that. Yeah, so first, if I press this button, the parking light turns on. If I press the second button, which is designated for the fog light, the fog light turns on. If I press the third button, which is for the headlight, it turns on too. And if I press it back, it turns off, works perfectly. Now the fourth switch, it's for the auto mode. So in the auto mode, when I pressed that, it directly turned on. Why was that? Because in the auto mode, the headlight is controlled by the ambient light conditions. Okay, so here this thing indicates the ambient light. So right now this dark one says it's night and bright one says it's day. Okay, so if the ambient light is very bright, the headlight turns off. Obviously you don't need a headlight when the ambient light is really good, right? So if it gets dark, the headlight turns on. If it gets bright, the headlight turns off. So what if, yeah, the auto mode, now the system is in auto mode and I'd like to control it manually. So if I continue to press the headlight button, there is no effect. Okay, see, it's on, and if I want to turn it off manually, it doesn't work. It only works through the ambient conditions. It's out of my control, okay, when it is in the auto mode. Now suppose it's on and it's in the auto mode, I turn it off. Okay, and now I turn off the auto mode and then I go and manually press this. I regain the control for the headlights. Okay, so I hope you understood the auto mode operation through this explanation. Okay, now you must also see this part here. Yeah, so here is a serial monitor, okay, and we are getting switch readings and sensor reading. So the switch reading is from these. When I change something here, when I press any of these switches, we get a change in these readings. And when I change something, oh my god, this one, when I change something in this, we get sensor reading, some variation in the sensor reading. I will explain it to you in a better way in a while, but just make a note, okay, whatever you observation, just do an observation here. So when I press this first parking light switch, just see, I have pressed and held the button, okay. So did you notice it changed to 682? And similarly I press this one and the value jumps here, the switch reading, it jumps to 700 and wait, what is that, 728, and here it jumps to 775, and here it jumps to 857. And here in the ambient light sensor, so it's night. When it is night, the reading is 1023, which is on the upper scale of the ADC, what do you say, the highest ADC reading. And as the light intensity increases, the ADC value decreases and decreases, and it tends to 0. Not 0 in this case, it's 7, but understandably. Okay, and when it wait, you need to see this, right? Okay, it's in auto mode. Yeah, so just see, when the ADC value go beyond a certain value, the light turns off. There is a range. We will see what is the range later. Okay, so this what do you say, this condition that if the ADC value is between some range, turn on or turn off the light, that is what we have programmed the microcontroller to do. Okay, so I guess this explanation was clear for you, a small demo. Okay, now next is we have to actually understand how this circuit works. Okay, so time for some theory classes. Hey, I also forgot to tell you one thing. Yeah, so why are we using a benchtop power supply? Why can't we just connect these LEDs to Arduino? Because Arduino works on 5 volts, okay, and the lamps need 12 volts. So you can't directly control a lamp with an Arduino. So we use a power source, external power source, and we, this relay is a switch. Okay, so like you press a switch by your finger, here the switch is pressed, like activated or deactivated using the Arduino. So we are interfacing, yeah, we are powering up the lamps using external source, but we are telling it to turn on or off using an Arduino through a relay. Now okay, let's come back to our theory class that we just started. So the main concept here we have to see is that, okay, wait, okay, you can see this is a voltage divider circuit, and so is this. Okay, what is happening here is we have a switch. Okay, so when you press the switch, it is detected by a microcontroller, and it tells relay, what do you say, the relay to turn on the light bulb. Okay, so this detection part, okay, what is that pressing? You are pressing something, okay, that is a physical action, right? So that physical action should be picked up by the microcontroller, and it should tell the relay through digital means like 0 1 0 1. It should tell it through through the binary whether to turn on or off. So you are changing an analog input to a digital output. So that is where we come to the concept of ADC, analog to digital conversion. So in any sensing type of project where there is a interaction of your changing of, like you are measuring or interfacing, yeah, you are actuating something using a physical change, you will need the concept of ADC. Okay, now how do we measure, like how do we get these ADC readings? That is where we are using the voltage divider concept. So we need a variable input, and usually this variation will be so small that you cannot directly measure it. So you need a means to amplify that measurement. Often you can use op-amps, but another way to do it is through voltage divider circuit. So let us do a voltage divider circuit here. Usually a voltage divider circuit has 2 resistors. One end of it is usually grounded and the other one is given a power, DC power. The other end can be a different, like you can have a negative power or something, but it makes it easier if it's grounded. Now let us label this R1 and this one is R2. So when we give some input to the ADC, we give this voltage across R2 as input to the ADC. Okay, this is the ADC input. This voltage is actually the ADC input. Now what happens when we have a sensor? Okay, the principle of this sensor, like the analog sensors, is that some physical change will impart a change in resistance in that sensor. Okay, and we are trying to utilize that change in resistance to impart a change in voltage or current, and that change we can measure it through the ADC. That is the concept. So in case of a light sensor, let's have, okay, like this, suppose this is a light sensor. When the light intensity increases, its resistance decreases. So when we have a light sensor here, suppose. Okay, so when the light increases, the resistance will decrease. Okay, and we know this basic electronics concept. When resistance decreases, the voltage drop across it also decreases. So if this voltage, if light increases, resistance R2 will decrease, and so will VR2 decrease, and ADC reading will also decrease, because this is directly proportional. Okay, I must tell you how this ADC and VR2 are related, right? So in Arduino, the ADC is a 10-bit ADC, so like you can have 2 power 10. Okay, so the maximum ADC reading, like sorry, you have 1024 bits of readings. So in Arduino it ranges from 0 to 1023, like totally it's 1024. Okay, so Arduino output is 5 volts. So for 5 volts you get the ADC reading of, like if the ADC input is 5 volts, then your ADC output will be 1023 volts. Okay, and if it is 0 volts, then the ADC output will be 0 volts. If the ADC input is 2.5 volts, then obviously it will be the half of it. Okay, how much is that? 511.5, I believe. Okay, so how do you do that? You know, cross multiplication and just do it. Like you can find it for any value in between. So that's how it is correlated. Okay, so VR2 is proportional to ADC. Okay, you understood that one, right? So now this is the thing. Now if light intensity decreases, R2 will increase and VR2 will increase and ADC will also increase. So that we can see in this circuit here. Let me start the simulation and observe the code. Okay, so see, this is what is it? This is light intensity is low. Okay, so when light intensity is low, resistance is high. When resistance is high, voltage drop is also high, and when voltage drop is high, ADC value is also high. So see here, ADC value is 1023, it's the maximum. So as the light intensity increases, the resistance decreases, right? Yeah, resistance decreases and voltage drop also decreases, and ADC value also decreases. Isn't it? You got, I hope you got the concept through this one. Okay, so now, okay, that's there. But what if we have a variable resistor on the top part? Okay, I'll indicate that with a red one. Okay, so what if we have a variable resistance connected at the top part, and this one doesn't matter. Okay, this R2 is constant now. We have a variable resistor at R1. Okay, so say the light intensity or any physical parameter increases and R1 decreases. VR2, okay, we are always measuring this voltage itself. It doesn't matter where you connect the variable resistor, we are always measuring the voltage across R2 itself. Okay, so here there is a inverse relation. Okay, you can try this out using the voltage divider formula. Okay, VR2 is equal to R2 into VCC divided by R1 plus R2. So here, if R2 decreases, means your denominator value is decreasing, means your overall value will increase, right? So that's the concept here. And ADC is always proportional to VR2, so ADC will increase. So now here, see, here light and your ADC reading, like your physical and your digital value, it's inversely related. If your physical quantity increases, your digital value will decrease. But here it's proportional. If your physical reading increases, it means your physical parameter or something increases, then your this one ADC reading also increases. I think it's better to view it through this resistors thing. Okay, so when you connect, it depends on where you are connecting your variable resistance. Okay, so you have to make a note of that. Now look at the circuit. Here we are connecting the variable resistance to the ground. Okay, we are not connecting it to the, we are not biasing the variable resistor, that's what we must say. But in this one, this is also a voltage divider circuit. This is R2 and this is R1. So here R1 is variable, here R2 is variable. Okay, so here we'll have a inverse relation. We'll see that in detail when we see the code. Okay, so this was about the ADC. Now what else we have to see? Yeah, we have to see this one, relay. Okay, you can observe this relay diagram here. What does it say? We'll redraw it here. Let me take blue, purple. Okay, so there are 6 terminals in this relay. Okay, and this is a energizer coil, and here we have 3 terminals. Okay, like this. So this is normally open, this is normally closed, and this is the energizer coil. So look, observe this. So normally closed means when this energizer coil is not energized, it's de-energized. Where is it connected? It is normally closed. Okay, that connection is called normally closed. Now you in case of a physical, like a real relay, I can show you this. Yeah, look at this. Okay, you will have 3 terminals here. Okay, normally closed, normally, wait, I think, yeah, these 3 terminals, these 3, this one, this one, this one. So usually the middle one will be the common, normally open and normally closed. So this one, which of these you should, how do you know which of these is normally closed, normally open? That you can actually observe at the back side of this. Okay, if you flip it, you can see it here. Okay, so this is the normally closed terminal and this is the normally open terminal, and here is your energizer coil. Where are we? Okay. So what we've done here is we have a, one second. Okay, so we have a lamp here, alright, and there are these connections. It's like this. Alright, so I think okay, here we have plus 12 volt supply, and here we have ground. Okay, so, and this is also, we are connecting it to ground. Now like this is not connected. Okay, like this thing is not connected to the energizer coil. And here, from here, we are actually having the Arduino output. Okay, so the Arduino output, whatever it is, like if it is plus, it comes here, it will energize this coil and it will flick this switch towards here, and what happens, this forms a closed circuit like this. Okay, so that is the connection that I have given here. But you can also do one thing. Okay, we'll redraw that. This is the lamp, and is the normally closed connection. We have the energizer coil and we have it like this, right? Yeah, this is the Arduino output and this is like connected to the ground. Anyway, now what you can do is okay, what you can do is this one you can have 12 volts connected to here instead of ground, and this you can connect it to the ground. This also works. See, when you have an Arduino input, this gets energized and this swings towards the normally open side and there is a closed circuit and the lamp will turn on. But the problem with this one is when this is not energized, okay, when this is not energized, it's like this, right? So suppose somebody accidentally touches this, what will happen? There is an accident impending. Okay, so that is why we go with this circuit, and I guess that is enough explanation for a relay. Okay, so pretty much explained everything about the connections and things. Okay, now it's time to understand the code, right? Okay, yeah, so let us see this one. Here first we start with defining the what is this? These are the ADC values. Okay, so how do we know it's 682, 775, 875? Well, we could like we saw previously, we could do it by pressing the switch and observing here in the serial monitor as well. But another way you can do it is you can take a multimeter. Okay, take a multimeter, set it to voltage mode. Which other modes are there? Okay, you can take it to the take it to voltage mode, much simpler. Okay, oh, what happened? Okay, oh, something is wrong. Alright, wait, let me reload this. So here we have the multimeter. We measure it through in the R2, right? So we have to measure this between the R2, connect the ground to the ground. Where is this? Oh my god. Okay, to the ground, and the positive to this midpoint, or you can directly measure it between A0 and ground as well. Okay, both are same. So now we start the simulation. Okay, so when in the resting state it's at 2.5 volts. So look at this code here. In the serial monitor, when no button is pressed, it comes at 511. Okay, which is actually the half. We already saw that. Okay, now suppose I let me this away. That I press this button, it comes as 33.3 volts. Sorry, 3.33 volts. So 3.33 times 1023 divided by 5. Okay, what do we get? We get 681.3 something, so approximated to 682. Now let's verify this in the code. Okay, what is that? 682, right? So that's how we deduce that, you know, if I press this button, you in a physical case you can do it that way. Okay, that's what I want to say. Now let's get rid of this one. Alright, now let's go ahead with the code. Yeah, so you understood how we got these, right? So for parking light switch, when I press this one, I get 682 as ADC reading. When I press the fog light switch, I get 728 as the reading. When I press headlight switch, I get 775 as the reading, and when I press auto switch, I get 875 as the reading. Okay, just making sure I'm recording it. Then this we are defining which output pin is for which light. Okay, so this digital pin 2 will activate the parking light, pin 3 will activate fog light, pin 4 will activate the headlight, and pin 5 will activate the auto LED. Then there is a offset. Okay, so here you see this one, where is it? Yeah, alright, yeah, see. Now suppose my output is, let's say, yeah, we got 3.33 volts, right? Okay, so this is a simulation project where everything is like very perfect, but in the real world nothing will be perfect. Okay, so you might not get 333 every time. You might get 3.35, you might get exactly 3 maybe. Okay, so we are having a buffer range. Okay, buffer range means there is a like possible higher value and a possible lower value. Every time you press a button, you will not get exactly 682 as your ADC reading. Sometimes you might get it as 690. Sometimes you might get it as 680 also. Okay, so you will have a highest and a lowest range. So you will set up a range, okay, so that it will not overlap with the other switches also. You will define a suitable buffer range. So if you get a value between anywhere in between this, you consider that as a yes, there is a button press. So that is the offset here. So here the offset is 5. So what is that? 682 plus 5, and here 682 minus 5. So this is your lower threshold and this is your higher threshold. So we are setting a offset here of 5. That is what it means. Then we have button state. Okay, so there are 4 switches, right? Now 1 minute. Okay, yeah, so you've seen this switch button, right? If you look at it from the side, it looks like this. Okay, these are the leads. This is in its resting stage. Okay, so when you press it, when you impart some pressure on it, you press it, it goes down, and when you let go of that pressure, it springs back again. Okay, so this button state variables, okay, these 4 variables, these are to indicate the button state of each of these these switches. Okay, you will understand that better later in the code. And then this variable is also used in a way to indicate the button press itself. Okay, we'll explain that later. And then integer state now. Okay, so this state now is a variable which will store the value that is obtained at A0. Where God, no, where is it? Okay, so the state now will store the value that is obtained at A0. Next, yeah, we have another variable that will store the light sensor reading that is obtained from A1. And here we are defining again yeah, these are the digital pins, right? You can have them as input or output. So you are telling the Arduino that no, these pins 2, 3, 4 and 5, they are designated as output, and A1 and A0 are inputs. Okay. And then yeah, you are when you indicate them as output, so they will have an arbitrary value. Okay, they can be high or low, you don't know that. It depends, like when you power on the Arduino, it can have any stray values, right? It can have, this can have high, low, there is nothing defined unless you define it. So we are telling that keep them all low initially, unless we change it, keep it all low. And that is that. And this is the serial baud rate, because we are down below we are having a serial communication with the serial monitor, right? So we define the baud rate. Then okay, so now we are coming to the function part. So we are using a debouncer function here. This is done mainly keeping in mind that when we implement this in the physical world, we need to have a switch debouncer. So you can have a physical one, but through code we are trying to solve that issue. Okay, so what happens here is this int state. So this state, this state is basically the ADC value. When you press this, whatever ADC value you get, that itself is the number, integer value passed on through this state variable. Okay, so you measure whatever is the physical value given to you. Like this state value, this is predefined. It's 682 for that parking light, and 775 for this one headlight, something like that, right? We saw in the beginning these four, yeah, 682, 728, 775, 875. So these are already defined. Okay, this state variables value is defined depending on which switch we are talking about. Okay, so but this state now variable, its value is like very volatile. It depends on the present at the moment reading from the analog 0 pin. Okay, so we take that value, the very updated value, and we are comparing that whether it's in that range. Now we define this range here. Where sorry, here, this one, we are checking if it falls in that range, like whatever value that we are measuring right now, is it falling in this range? We are measuring that. So, and once we measure that, like we find that yes, it is within the range, we don't directly jump off and say that it's an affirmative action. We wait for 10 milliseconds and check that state again, and if again within that 10 milliseconds it's still within that range, then we conclude that yes, it's a positive input. So we tell that yeah, there was a button press. We conclude that yes, there was a button press, so we return the value as high. If within that 10 milliseconds the microcontroller does not see that the value lies within that range, okay, so like first it measures that okay, it's within this range, and then in the next 10 seconds it measures that but it's not in that range, then it will just give the value as low. Otherwise, if repeatedly within that 10 milliseconds, if it's still in that range, then you can conclude as high. Okay, now coming to the main code. Okay, so first we are checking again. Now like this was a very this is the function, right? So now we are checking individually for each of the switches. We are checking if that switch is pressed or not. Okay, so parking light switch, this is already defined as 682 at the top, right? You remember that one, right? So when you pass 682 as state here, 682 as state, and your concurrent state is within that range, okay, and then you get a high as a return from this, then you compare it. Yes, if it, yes, I pressed it and it is high and the button state is low, means see here, this, no, this one. Okay, so this is at the rest condition, and okay, we are taking it as synonymous as low. This one is active condition. Okay, this is synonymous as high. So if the button state is resting and my EDC value is, yes, high. Okay, now imagine the EDC value as your finger pressing it. Okay, so here there is no ADC value. Okay, we didn't get a suitable ADC value, so it's resting condition. But then we got a suitable ADC value and we want that ADC value to activate the switch. Okay, so that's what here. So if it is low and then we get a ADC value and then we get a ADC value, we, what do you say, we press on that, how do you say, like you pass on that state onto that switch. Okay, so what are you doing? It's already low, so if this condition satisfies, then you consider that the switch is pressed. Okay, if there was no, first of all, if it was like this and then you got a ADC value, okay, then it goes into the active state. And also what we do is we turn on the toggle the parking light. If it was already off, we turn it on. So see this one, digital right. Okay, this one indicates the output pin and this indicates the value 0 or 1, high or low. So your digital read, you're reading at this pin. Okay, you're reading whether it is high or low, and then you are toggling it. If it was high, you make it low. If it was low, you make it high. Because see, we are having only one switch for a light. Okay, and we don't have one switch for turning it on and one switch for turning it off. So we are basically mimicking the real world action through the code. Okay, so this is nothing but the button state. This itself is the button state variable. It is low, and then if the ADC is high, then you make the button state as high. Okay, and once you make that as high, your job was to turn on the light. And once you turn on the light, you don't want this to be staying here, right? You want to, and then yeah, see, also you will not, press it and hold it. You'll just press it and leave. So once you leave that, obviously the switch must come back to its position and the ADC value will go away. So now the ADC value is very volatile. As long as you hold the switch, it's there. When you leave it, it's not there. And then the switch must also bounce back to its old position. So when you leave the physical switch, you want it to mimic in the software also. So it was high, it was already pressed. Now you left the physical switch, so you want the digital switch to also come back to rest. So that is what we have done here in this part of the code. Same thing we do for the fog light also, but here the fog light switch, this value will be 728, I believe. Okay, you remember that, right? So it's the exact same thing for fog light. It's the exact same thing for the auto LED light also. Okay, in case of the headlight, since we are its operation is also intertwined with the auto mode, we have an extra variable here called pressed H1. Okay, so in all other cases, what happens is if your ADC value is high and the button state is low, you will toggle the switch, right? Here we are actually setting one variable value, okay, as high, and then we go to this condition. Okay, we go to then we pass it on to the auto mode section. Okay, so you remember that we turned on this one. Okay, we don't turn on, we call that as set one value. Now we move on to this auto mode of operation, we are what we are getting the reading from A1 pin. And then what we are doing, we are checking if it is within the range. Now this range we can change it if you want. Okay, so we are checking if this sensor range, this we were sliding it here, right? Yeah, that ADC range. Okay, we are defining 256 as the benchmark. Okay, if this sensor reading, whatever sensor reading is there, if it is greater than 256 and the auto LED is high, means we are in auto mode. Okay, if the let's start simulating this one. Okay, serial monitor. Yeah, see, if the sensor reading is greater than 256. Wait, oh, I have not turned on the auto LED. Okay, turn this on. Okay, yeah, so if the sensor reading is greater than 256, your headlight will be on. Okay, if the sensor reading is less than 256, your headlight will be low. See, that's the threshold. So you can set it at any value as you define suitable. So you might want to set 595 as the threshold. Below that, above 595 you want it to be on, and below that you want it to be off. You can define that by changing here. Okay, and then yeah, here we come to that pressed H1. So when I press it manually, okay, I also want to check if the auto mode is on or off. So that is what we are checking here. So there was a manual press on the, yeah, this is, I'll call this as manual button. Okay, so there was a press in the manual button and you check if the auto mode is on or not. So here the auto mode is not there. So what do? You let this button control the lamp by toggling it. Like if it was on, you make it off, and again the button stays like I said. So now you turned on the light or turned off the light. Now the job is done, so you release the switch, so you reset it to 0. And similarly, if you press this button and the auto mode was on, means the auto LED was high, this one, then you just ignore this switch. You do nothing, but you just release the switch. Okay, yeah, that is that. And this, finally here we have a set of code to print the A0 and A1 readings onto the serial monitor. That's it. Okay, so you switch reading, you are getting it from A0, and the light sensor reading, we're getting it from A1. Okay, so that's it, that's the code. Now yeah, so that was the whole explanation about the body control unit project. I hope you understood everything. If you didn't, you can comment down below and I'll do my best to clarify that. If you have a lot of doubts, I might as well do a follow-up video for this. Happy learning. Thank you. See you next time.